All right, so part three, part two. Part two of the part three just means that we already did part one and two, and then we did part three, but now we have to do a second part of part three to make sure we get the other part of the part that we missed. So lots of part talk. You can see Riggs down there. He's like, yeah, that's right. Part two. Part two. Yeah, you just don't want to be the other guy. Okay? So to go over the Google form, you did a fantastic job of this. You said that the slope was positive 2 over 1, and you said that you had a y-intercept of negative 3. Nailed it. That's wonderful. And that's fantastic that you're able to look at the equation and be able to do that. That's very, very crucial. So I think that what you're going to be able to do with what we're doing today is you're going to be able to pick up this part of it. So if x is 2, then y is, and what this would look like is if you set up a table, and I said, okay, so if that's 2, and you used this equation, what would that look like? All you do is substitute the 2 in for the x value. 2 times 2 is 4, minus 3 is 1. So we get a y value of 1. I believe you put negative 1. And that could be a simple mistake. I don't know, but just it wasn't the correct answer, so I'm going over it. Super impressive on this. You got x equals negative 7. You did a great job. You started with the smaller variable. So I'm just going to go over it because I think it helps to see it. But this was very impressive. Start with the smaller variable. Like perfect. And then for what was the slope as a fraction, you nailed that as well. You saw negative 8, so down 8 over 1. In what directions will the rise and run move? That's going to be down and right. So this one was left blank, and I think I know why, because it's just the format of the table is written sideways instead of vertical. So anytime you see x equals these values, all you have to do is put it into an xy table, which I know you can do, 0, 1, 2, 3, and substitute it into the equation. Okay, so let me just move this out of the way. Okay, missed it. There we go. So 2x minus 4. So substituting it in, 2 times 0 minus 4 is 0. So that's going to be, take away 4, you get negative 4. And then 2 times 1 minus 4 is 2 minus 4 is negative 2. And this coincides with our positive 2 for the slope. You can see that it's going plus 2. Guess what? Next one's going to be plus 2 as well. So that's going to be 0 and then 2. And I would highly encourage you to check all of those. 2 times 2 is 4, minus 4 is 0, check. 2 times 3 is 6, minus 4 is 2, okay? I'm just trying to give you patterns because they're there all the time. That's what's cool about algebra. It's all following rules. All right. You found the slope for this, and you did that by the change in y, which was plus 3, and then over x plus 1. So you did 3 over 1, and you nailed it, okay? Now, whenever we're looking at a table, and this is what our focus is on, which is why we're doing part 2 to part 3, is using this as your slope, okay? And there's 2 ways you can find this, and that's always going to be if you can see that x is 0, there's your y-intercept. So I already know that the y-intercept is positive 1. So this is going to be 3x plus 1. But the way that the thing that we're really emphasizing today, and the thing that you seem to be struggling with, is whenever you substitute any of these x values in right here, like I'm going to pick 2, okay? 3 times 2, that's 6. But whenever I substituted 2 in, it should have been 7. I got 6. So how do I go from 6 to 7? Plus 1. Then you just wrote your entire equation. That's all. That's it. So I'm going to clear this off. I'm just going to do that one more time. So you said that your slope was 3. All I got to do is pick any x value. Okay, 5. I'll do 5. 3 times 5. 3 times 5 is 15. So that means that this number should say 15 right here. But it doesn't. It says 16. So how do I go from 15 to 16? Plus 1. And now you have this to test the others to make sure that your equation is correct. Like, for example, I'm going to use 4. 3 times 4 plus 1. Let's see if y equals that. It should equal 13. So 3 times 4 is 12, plus 1 is 13. Cool. Check. That's what we're doing today. That's the part we messed up on. And is it a positive or negative line? Well, it was increasing by 3, so we had a positive line. And you said because there were no negatives, which is another way to say that it was positive. And what equation did you get from the table above? Y equals 3x plus 1. So you nailed it on the 3x. You know it's a positive line. All we have to do is be able to substitute and then find out, does the result match the table? So I know that you've been gone a while. I wanted to leave this in here, and I want to keep talking about it. Slope is your rise, how far up you're going. Run is your x, how far side to side you're going. B is going to be your starting point. So for example, y equals 2x plus 1. You would be starting at plus 1 and then using our rise over run. Up 1, 2 over 1. Up 1, 2 over 1. So whenever you have this equation, you can see that you're going to put an x value in. You're going to pick a number and put it in. If you wanted to put 2, then you have 2 times 2 is 4 plus 1 is 5. So that means you would have coordinates of 2, 5. 2, 5. Bam, there it is. And that's how we can plot that point as well. So what we did last time is we talked about having these x values and substituting them into the equation you're given. So 2 times 0 plus 1. 2 times 0 is 0 plus 1 is 1. So that you can see there's your y-intercept. There's your y-intercept. 0, positive 1. Okay? And then substituting them more and more and more, or you can use the slope to go. It's going by plus 2. And you could have also gone, I know my slope is 2 over 1. Up 2 over 1. What we did last time, the previous last time, was if given 2 points, you could definitely generate the coordinates. We just went over how you do that. Now, if you're given a line with 2 points, you can figure out what the slope is and what the y-intercept is by just counting the rise over the run. 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. And then can you simplify that? 8 divided by 4 is 2. Okay, so that is how we can verify our slope. And then we can add all the other coordinates in. So we're at, let's see. If we go up 1, 2 over 1, up 1, 2 over 1, up 1, 2 over 1. And look at that, it found our y-intercept as well, which is right here, which is whenever we plugged it in on the previous slide, it had 0, 1. So all this stuff is tying together. And I know it's a lot. It's all tying together. So you see this guy? Look at him. Put another tier there for him, okay? Let's get some. He's a punk rocker. Let's get an ear. Put a little earring on there, okay? And let's get like the Rock, you know, like one of his eyebrows. Like serious, bro. Let's put a little soul patch there. All right. So the procedure that we were going through last time is what is y changing by, what is x changing by, and set it up as your fraction. You nailed that 100%, like you got that. Let's just, so plus 1, okay, so what's y changing by? Plus 1. What's x changing by? Plus 1. So put them over each other. 1 over 1 equals 1. Okay, so we've got 1x. Use your slope, which is this right here, that you just came up with, to substitute 0, 1, and 2, and 3, etc. into your equation. So y equals 1 times 0. 1 times 0 is 0. Okay? So that would give us a answer of 0. Is that what was supposed to come up when we substituted 0 in? See, look, we took and we put it right there. It says that we should equal 0. Does that equal 0? No, it does not. How do you get there? How do you go from 0 to 1 plus 1? You just wrote your equation. Now we check it. Y equals 1 times, let's stick in 2, okay? 1 times 2 is 2. This says 3. Plus 1 is 3. Check. That process over and over. The questions I'm saying out loud are the questions I ask myself precisely exactly whenever I'm going through this process. This is the third way for you to write an equation and connect it to a line and connect it to a table and coordinates. So just to review, I prefer you hit pause when you're comfortable and try and write the equation before I reveal the equation. Okay? So find your change in y, decreasing by 3. Change in x, increasing by 1. Now you have the slope portion of your equation. This is what you need. Okay? Now we substitute x values in. You pick any x value you want. I always prefer 0 because I think it's the easiest. It tells me what I need to add or subtract from nothing. So what this would look like is y equals negative 3 times 0, an x value. Any x value from over here, and I chose this one. Negative 3 times 0 is 0. It says it should be 3. So how do I go from 0 to 3? Plus 3. There's your equation in its entirety. Whole entire thing right there. Now you can check it. Let's see what that looks like. Y equals negative 3 times, let's do 1. So when we solve this, we should get 0 because we got our plus 3 and we're checking it. So we should get 0. Negative 3 times 1 is negative 3. Negative 3 plus 3 is 0. Check. And you can take all these coordinates, you can plot them, you can verify all this information. I only have this here for what we did last time. Highly encourage you to pause the video, make an attempt. We're going to go over every single problem that we did last time as well. So, I mean, there's going to be no shortage of examples and how this is done and how the procedure is done. Find your change in y, plus 1. Find your change in x, plus 1. Now we've got y equals 1 over 1x. 1 divided by 1 is 1. So I'm going to rewrite that as this. Okay? Now I'm going to pick 0 as my x value. Okay? Y equals 1 times 0. What is 1 times 0? 0. Well, how do I go from 0 to negative 3? Because I should have got negative 3. You do minus 3. There's your equation. That part's done. That's all we're doing today. That's it. I'm going to show you again using a different x value just to verify that this is the equation. Okay, so I'm going to use 2. Now when we solve this with the x value substituted in, we should get negative 1. 1 times 2 minus 3. 1 times 2 is 2. 2 minus 3 is negative 1. Bam! That's what we're looking for. This is your equation. This is the thing you're looking for. Let's see if it's right. X minus 3, 1x minus 3, same exact thing. Perfecto. Pause it. Try it. What is the change in your y value? Plus 3. What is the change in your x value? Plus 1. 3 over 1. We're putting an x next to it, and we're putting y equals. This is the part we need. Now we will pick an x value. I'm going to choose 0. I'm going to put it in for x. Y equals 3 times 0. Okay, so when I solve this, it should equal negative 1. 3 times 0 is 0. But this says negative 1. How do I go from 0 to negative 1? Minus 1. That'll put me at negative 1. Now I'm going to pick another x value, 2. I'm going to try it again with my full equation. Okay, so 2, I'm substituting it in for right here. You'll see me write 3 times 2 minus 1. And that's 6 minus 1, and we end up getting 5. 5, check. This is proof that this is the equation. So we create the equation, then we check the equation. Let's see if we're right. 3x minus 1. Pause it. Try it. This is one where I want to provide an example that if you're sitting there going like 10 thirds, 8 thirds, what? And then you see two whole numbers, just see what they're changing by to get to the whole numbers. From 4 to 2, that's minus 2. Just make sure on the x side you do the same thing. 0 to 3 is plus 3. Negative 2 thirds x. This is why it pays to have 0 in your coordinate table, because we know that's already plus 4. None of the ones we're going to be doing today have fractions in them or anything. But that's why it pays to know where your information's at. Notice we didn't have to do any work on that. Negative 2 thirds x plus 4. Okay. I'm going to go through the same procedure over and over and over and over and over until we get through the problems that we were supposed to have done last time. Just to be honest, you got none of them correct, and it was because you missed the y part every time. The plus b or minus b, that y-intercept you missed every time. So negative 7 to negative 8, minus 1. 0 to 1, plus 1. So we got negative 1 over 1x. And we know that that's the same thing as negative 1x. I'm going to pick an x value, and I'm going to substitute it in for x. Y equals negative 1 times 0. Now it says I should come out with negative 7. I don't think I'm going to. It's negative 1 times 0, 0. How do I go from 0 to negative 7? Minus 7. This is our theory. Now we test it. I'm going to pick another x value. Notice I've been picking 0 and 2. You can pick any ones you want. Just make sure it's connecting to the coinciding y value. And I'm going to plug it into our checking equation. Y equals negative 1 times 2 minus 7. Negative 1 times 2 is negative 2 minus 7 is negative 9. Check. So the equation is officially negative 1x minus 7. You should be able to, regardless of what you come up with, you should be able to pick any x value from the table and put it into the equation that you're giving me, and it comes out with these y values. You'll know if you're giving me the wrong answer. Negative 6 to negative 2 is plus 4, plus 1, so that's 4 over 1, which is just y equals 4x. Now I'm going to pick 0 and substitute it in for x. This will tell me where I need to go, adding or subtracting. 4 times 0 is 0. How do I get to negative 6? Minus 6. Let's test it. I'm going to use 2, plug it into x. 4 times 2 is 8 minus 6. 8 minus 6 is 2. Check. That is proof that this is our equation. Y equals 4x minus 6. Take any of the x values and plug it into that, and you will know if you're right or wrong. Plus 1. Plus 1. We got y equals 1 over 1x, or just y equals 1x. I'm going to pick 0 as my x value, plug it into x. Let's find out what I need to add or subtract. 1 times 0 is 0. How do I get to 4? Plus 4. 0 plus 4 is 4. So now I'm going to take this and check it. I'm going to use the x value 2, and I'm going to plug it in for my checking equation. Y equals 1 times 2 plus 4. 1 times 2 is 2, plus 4 is 6. Proof. 1x plus 4. And you can also represent it as x plus 4, because we know that when there's just an x, there's an invisible 1. Plus 1, plus 1, y equals 1 over 1x, or y equals 1x. Same thing. I'm going to choose my 0, substitute it in. Y equals 1 times 0 is 0. 1 times 0 is 0. How do I get to 5? Should be 5. I add 5. Now I'm going to take this equation, I'm going to check my answer. I'm going to take the number 2 out of my x values, plug it in for x. 1 times 2 plus 5. 2 plus 5 is 7. It's exactly what it should have been. Proof that this is correct. 1x plus 5. Okay, so this is increasing by 3, increasing by 1. So that's y equals 3 over 1x, or just y equals 3x. I'm going to take 0 as an x value, plug it in for x. 3 times 0 is 0. It should be negative 6. How do I go from 0 to negative 6? Minus 6. This is my testing equation. I'm going to use my testing equation to insert another x value. I'm going to use the x value of 2 and put it in for x. 3 times 2 minus 6. 3 times 2 is 6, minus 6 is 0. So that's exactly what that says. This is my equation for sure. 3x minus 6. 2 to 0 is minus 2 plus 1. Negative 2 over 1x. We know that we could also rewrite that as negative 2x. I'm going to take 0 as my x value, substitute it in next to my slope. Negative 2 times 0 is 0. How do I get to 2? Plus 2. Okay. This is the equation I'm going to check with. Let's see if something else works with it. Because if it does, we're good. I'm going to take x value of 2 and put it in for x. Negative 2 times 2 plus 2. Negative 2 times 2 is negative 4. Plus 2 is negative 2. Is that what we got? Yep. Checks out. So this is for sure the correct equation for that table. Three to 1 is minus 2 plus 1. So we got negative 2 over 1. Or we can simply write it as negative 2x. I'm going to take 0 as my x value, and I'm going to plug it in for x. Negative 2 times 0 is 0. Should be 3. How do I go from 0 to 3? Plus 3. I'm going to take this equation, I'm going to use as my checking equation. I'm going to choose a different x value, 2. I'm going to substitute in for x. Negative 2 times 2 plus 3. Negative 2 times 2 is negative 4 plus 3 is negative 1. Exactly what it should have been. Perfect. This is for sure my equation. Negative 2x plus 3. Negative 2 to 0 is plus 2. So we have 2 over 1. Okay, change in y, change in x. We can also rewrite this as simply 2x. I'm going to take 0 as my x value, and I'm going to insert it into my x position right over here. 2 times 0 is 0. How do you get to negative 2? Minus 2. This is the equation I'm going to use to check to make sure that it is correct. Whenever I plug in any x value in here, it should come out to its corresponding y value. So I'm going to choose 2. Put it in for x. 2 times 2 minus 2. 2 times 2 is 4. Minus 2. 4 minus 2 is 2. Is that what it's supposed to be? Oh yeah! Nailed it. So 2x minus 2 plus 6. So 6 over 1x, y equals. We can just go ahead and say 6 divided by 1 is 6. You can just go ahead and do 6x. I'm going to use 0. Substitute it in for my x value and see where I'm at. 6 times 0 is 0. Dang, I don't need to add or subtract anything. Look at that. It's supposed to be 0. Check. Awesome. So the equation here is 6x. Awesome. That was an easy one. But here, I'm just going to go back, and I want to show you one thing that happened in every single one of these. Okay? I'm going to highlight it in blue. So you see minus 7, 0, negative 7. Minus 6, 0, negative 6. Plus 4, 0, positive 4. Positive 5, 0, positive 5. All the pieces connect. Negative 6, minus 6, 0, negative 6. Plus 2, 0, positive 2. Plus 3, 0, positive 3. Minus 2, 0, negative 2. The y-intercept was in every single table already. What we were doing, the whole process we were doing, was checking the table by creating the equation. So this is, we're adding anything. So plus 0, minus 0. Look at that. 0. 0 is your y-intercept. Okay? So the expectation is coming up with your slope, substituting an x value in, finding out what you need to add or subtract, and then check the equation. There's no reason why you should turn in a single one of these without the correct answer. You should be able to check every single one. This is why I've been emphasizing checking for so long, because we were going to get to this point. Please contact me if you have any questions.